Welcome to the July edition of the CAFFE seminar series. So today we're delighted to welcome two speakers on the topics of artificial intelligence and machine learning. So first, Sergio Correia from the Federal Reserve Board will present a paper entitled Unlocking Economic Data with LLMs. And then Svetlana Bryzgalova from LBS will give a paper entitled Almost 200 Years of News-Based Economic Sentiment. So thank you again, Sergio and Svetlana, for accepting to present in our seminar. So just housekeeping. So each presentation will last 25 minutes and will be followed by 10 minutes of Q&A. And if we have time, there will be a final discussion at the end. We encourage all participants to turn on their cameras so it feels like a more interactive seminar. And Sergio, the screen is yours.
Thank you. See. Okay, can you see this screen?
Yes, very good.
Perfect. So this paper was originally, it's more than a paper, it's a compilation of papers, of work I learned from different papers. And I learned a few things that I thought useful enough to spend some time presenting it, and it escalated a bit more. There's a usual disclaimer here from the Fed board, but also a few other disclaimers that I'm not like suggesting any tool is better than the other, etc. I'll leave this to you, but I'm gonna read it completely because it's very detailed and it was approved by lawyers. So today I'm gonna talk to you about something that I think has relatively understudied or under-talked with LLMs and everything economics. I've seen a lot of people discuss how to use LLMs or ChatGPT to code, to like help to write titles, to help like do many crazy things, but I really haven't seen enough people talk about how to use a simple use case, which is I want data for aggregation, and in order to get the data, I have a document that is not in the way I need it. So this talk is about that. It's about how to get data that you can use for an empirical paper with an LLM such as ChatGPT or Claude. I split it into two parts mostly. The first part is why do we want this, or why do we care about using these tools to get data? And the other one is a brief introduction to the how, because it turns out that this is relatively easy. With some basic Python knowledge or an array that knows Python, you can get this done in 2 days. So first, why? Why do we want this? Why do we care about this? This is probably obvious to you, but we tend to use a lot of very well-known data sets, CompuStat, banking call reports, etc. And the problem we have with this data set is that it's hard to come up with new things if the only thing you're using is CompuStat. Everyone has looked at CompuStat, every possible identification, natural experiment, anything interesting, you've already had 1,000 people, very smart people looking at it, and it's unlikely you're gonna find something new or you're gonna be able to answer new questions. So the alternatives I've seen and used in the past are, for instance, confidential data sets, for instance, lending data from credit bureaus, private data sets that you pay money for. Something else I've done a lot is historical data sets. You have data stored in an archive, the basement of a library, you scan it, digitize it, you can use it. And the third alternative that I'm encouraging today is non-traditional data, which is data that is not stored as a number right now ready to use, but in another format that you want to convert it to a number. And let me give you a few examples of this. The first example is Svetlana's paper that does this in an amazing way, and I'll let her explain about it. Another paper, very recent as well, is Bybis that uses a lot of textual data combined with LLMs in order to create expectation data that he's going to use as a second step in his analysis. This is in the vein of the standard things, so stuff we have seen and understand. But things get a bit crazier. Something else I've seen is use the facial expressions of Fed chairs and how that can predict stock and equity and bond returns. So for instance, you have seen papers where the monetary policy decision matters. Then we have seen papers where the actual sentiment and the words that were said matter. And now we're adding a third component, which is the face you had, where you worried or anxious or excited when you said those words. And we have seen that those have predictive power. For me, it's super interesting. And you can keep going on, and the level of creativity I have seen is crazy. So as my last example, for instance, there's a recent UGE that studies textbooks and the faces in the illustrations of textbooks and what can they tell about gender and race. So they get like thousands of pages of textbooks, find the faces in these drawings, and do a bunch of a pipeline in order to extract the face, identify the skin color of the face, classify it according to a given race and gender. And basically, they use all that, and then in the actual regression, they use the gender and the race in order to understand more things. So the first step in most of this analysis is I want data, but there's no obvious data, and you can create it from text, image, sound. And this is a bit what these LLMs are doing. And you can use now these LLMs for audio, for video, etc. And you can also use other tools that predate LLMs. So the first thing that is basically that you can use AI to unlock data that was previously unlocked. And in examples that the Fed have is we have some data sets, that documents, PDFs, memos, that we cannot really export as a table, but with LLMs, you may be able to extract them and actually then use them to run regression. So the name of the game is to get this underlying under the water non-traditional data into a tabular format, which then you can use as normal. And to give you a few examples that are seeing or used. At the board, I'm sorry, in the US government and also in the EU, you have proposals for regulations that are then commented on by either lobbying groups or the general public. And a lot of times, these comments end up with thousands of comments, PDF, text form, etc. And an important policy question is how do different groups react to a given law? You can see this in banking. You can see this in this example about the national wildlife refuge system. And the problem is, okay, how do you deal with the comments? Are you going to hire a bunch of RAs or interns to go through 30,000 comments and extract the relevant information about who is who in the comment, what are their opinions? This is not only very expensive, but a problem I've seen when you hire people to automate these things is that the bias of a given array may be different than the bias of another array. They may work differently, etc. So you end up with sometimes inconsistent results. So to just attach the document to ChatGPT or any other similar tool and start asking questions. Who was the author? What were they thinking of their underlying justification? And you can use these answers as a sequence and getting data a processed state. So this is the first example. How to get a lot of public data and how to parse it fast in a few hours.
Sergio, yeah, the connection is not particularly good, but I'm not sure if you can do anything about that.
Yeah.
It's a bit discontinuous. Yeah.
If it gets bad, I have a wireless router, which is a bit slower, but a bit more stable. Can you hear me now or not very well?
It's nice, fine. Yeah.
Okay. Let me, I had my phone close to the laptop, so maybe moving it away help. I'll also try to talk very, very slow.
Thank you.
So my first example is dealing with thousands of data, of documents, PDFs, etc. And it works incredibly easy, even without giving any prompt or modifying the comment I have. Another example I have used is historical data. So for another paper, we wanted to extract data that was stored in a PDF in the middle, somewhere in the PDF. And the way we dealt with it is we asked ChatGPT, hey, I have this snippet of text, 2, 3, 4 pages of text that talk about a given German firm. Please find the text relevant to employment and give me the output as a table or as a JSON format. So in that sense, I can use it not to create data, which is sometimes controversial because people are sometimes reluctant to believe the data generated by a computer, but to extract data that is out there already. So that's the element. To extract data, historical data in this case. And as another example, from the same research paper, you can also use these to create data that was not there. You're not extracting anything that existed in the document, you're making up something new. So in this case, I'm asking ChatGPT for help in identifying real investments. So within the firm description in this historical document, there was information about what did the firm invest on in terms of warehouses, factories, roads. And I'm asking ChatGPT, please list me these investments. And then in a second step, I'm asking them to classify in a set of categories in order to see how much are they invest. Is the connection still bad, Laurent?
Yes, the connection was fine. I mean, it was better, I thought.
Okay.
Thank you.
Thank you. And then you can also use this more creatively. For instance, a common problem I have with merging data sets is that they often have different identifiers. So in the example I have here, I have bank names, and they have very, very different names. One bank may be the Wheeling NB, the NB of West Virginia at Wheeling, and there's many variants depending on the data set. And in this example, what I did is basically I asked ChatGPT for help in providing an example. So it gave me the right example in this case. And I'm not gonna trust ChatGPT on this at face value. I'm gonna validate it. But the fact that I can run a loop and in 20 minutes I can get 1,000 bank names and their matches, where I would have instead had to search by hand all these possible combinations, saves me a lot of time compared to the alternative of basically either doing it myself or hiring somebody, at the risk that also entails mistakes in the data. So this is this level of work is very basic in the sense that it's a stuff where we spend 90% of our time as researchers, but we don't talk about much, but this saves an incredible amount of time. And this is very useful, especially for smaller groups. So if you have a big budget for RAs and interns, this is very useful because it can get you up to speed in no time. And then my second insight is that this is very fast in the sense that any of the examples I gave could have been done by you or by an RA or an intern. But what you get with this is you can wrap it in a loop and you can get it done very, very quickly at the cost of maybe $100, $200. First, 50,000 PDFs a few months ago, and the cost was about $300, which for me it's expensive compared to running OCR or running another tool. But when you think of it in terms of what you saved, which is having to hire and train people, it actually is quite cheap. So this allows you to do what you couldn't do, especially true, for example, if you're a PhD student. I would have liked to have this as a PhD student where I was unable to hire anyone. Now, let me tell you a little bit about how to do I'm not going to do the live demos. There's a link there. But let me tell you a bit how to do it, because it's not that difficult, but there's three things that you will need to understand. And the first, and basically it's about how computers think in this sense. So the first thing is that right now, you start with text. You start with an actual sentence, a paragraph or more, and then you want to understand basically how computers take this into numbers. And this first step is called tokenization, and it's very trivial. It basically consists on converting every either sentence or word or syllable to a given number. And the most trivial example will be just to convert it to the ASCII representation, but there's also other examples, which is what ChatGPT and the more sophisticated tools do, which involves, in this example, for instance, it involves having special numbers for very common words. So for instance, the word decline has its own number, but the word in this example, the number 2023 doesn't have its own word, its own number. It actually is decomposed into two numbers. So you can, in this step of tokenization, which may feel a bit trivial, there's something that you can learn already. So you can learn, for instance, that you're going to get different results if you convert everything to lowercase that if you actually respect the original case of the documents. Something else that you're going to learn is that every tool has different biases. So for instance, ChatGPT is bad at dealing with numbers above 3 digits because it's only trained to encode up to 3 digits into a token. So in that sense, it fails to do math where it gets more complicated. And knowing this allows you to better know what to do. For instance, something that was very common when I was doing Python is I just convert everything to lowercase and then run it. But that's not what you need to do. Now, the second step that you have is that, well, this is nice, you have a vector, but every sentence has a different length. How can you put this into something that expects the same length, like a regression, where you need to have like variables x1 to x100, not x1 to something that changes? And what you do here is called embedding. And embedding is very, very powerful, and you can use it for get interesting insights even without calling the LLMs. So an embedding is a way to think of it is the first step of running ChatGPT is converting this varying length vector into a fixed length vector of usually 1,000 numbers that represents a semantic space. Think about principal components or think about latent analysis. Basically, you create a vector where it's not trained by you, but every single cell is going to represent some meaning. So for instance, this is a real example I gave. And what I found is that, for instance, the language, Spanish, English, German, etc., is often represented in one of the first numbers. The tone, aggressive or informative, etc., is also represented, and different parts of the sentence, the content, the meaning, positive, negative, etc., are in this embedding vector. So if you don't have ChatGPT and you just want to use embeddings, you can already do a lot of things. And let me show you some of the things you can do. And I did them by myself just to be sure that I'm not talking something that is not going to work well. But suppose you are able to run a bunch of documents or a bunch of opinion, text, etc., and you have your vectors. Once you have vectors of fifth length, of what you can do is you can just do algebra. You can do linear algebra. You can take the average opinion by taking the average of the vectors. You can compare the difference between two opinions by taking the difference of vectors. And you can also get the distance between different vectors. So in the example I gave, in the first example I gave about opinion of different groups, you can get one opinion, the second opinion, and then compare the distance between the vectors in order to see a measure of similarity of their opinions, for instance. And this is something you can do extremely cheap, maybe even in Svetlana's example, I don't know if you've seen, but the cost for running embeddings has fallen a lot. And once you have embeddings, you can do not only linear algebra, but you can classify the embeddings by like optimist, negative, by category, subject, topic, etc. And there's multiple very good classification mechanisms, and you can even run them in Stata. So you get your embedding of a given word, of a given text, and you can transpose it, and you can call these variables x1 to x100. And then what you're going to do is you run these variables either in OLS or Lasso or any of the more sophisticated tools, and you can use this for prediction. And it works quite well. The typical example is you have Amazon ratings and the text that goes with the number 1 to 5, and you can see that the text, when you embed it, predicts very well the ratings. You don't have to go to the more expensive and sophisticated tools. Just with embeddings, you can get a lot from the text. Now, you can go to the last step, which is ChatGPT. And the best way for me to explain ChatGPT, and probably like 90% of you have already used it and understand it, but it is almost like an autocomplete, like the ones you will see in Gmail, WhatsApp, Teams, etc. But it's on steroids. It's this is an older description from half a year ago, and even back then it was trained on about almost 2 trillion parameters. It had 13 trillion tokens, so an insane amount of data. And we are now at the level where we are scratching the amount of data available. So we don't know where to get more data for this, for the next version, because we have practically used every possible data set out there. The problem of this ChatGPT and other tools is that it doesn't help me when I have my own data, when my own documents. And this is example, the typical example. If you ask ChatGPT how many bank mergers there happened 1 or 2 years ago, it's going to tell you the right number. I don't know how he got it, but this is the actual number that we know at the Fed. But if I ask how many mergers they happened this year, or how many mergers happened 100 years ago, it's going to have no idea because it was not trained on that data. And the answer for that is what is called RAG, which is fairly straightforward approach, which is you're going to you're going to talk to ChatGPT, and you're going to give it some context. You're going to basically copy paste the relevant text, and you're going to say, look, ChatGPT, I want you to give me these 5 pieces of information based on the text I'm going to paste at the very end. If you don't know how to do it, just say, I cannot do it. This helps to avoid false or fake results. But basically, this is what everyone is doing in terms of RAG. The only sophistication happens where you talk about how to get that context. Sometimes, if you have a small document, you can paste everything. But the problem you have is that sometimes you have a document that has 1,000 pages. And that is either impossible to run or is extremely expensive because they charge per word. So then what you're going to do is you're going to do something called
Sorry, we actually couldn't hear your last few sentences.
Take the embeddings that you computed before from here or from the next one.
Yeah, we missed a few sentences. I think the connection broke for a few sentences. Okay. Yeah.
Perfect. So basically the solution is fairly simple. It involves adding context to the LLM, and that basically entails finding the right text. And the problem is that sometimes there's too much text, and the document you have is too big, too complex, and you cannot run everything. So the solution for that involves basically running an embedding in the entire document because embeddings are cheap, and then finding the relevant text. So for instance, what I do here is if I want to search for a text relevant to a given topic, I'm going to run the embedding and get the documents or the sentences that are more similar, more like have a smaller distance to my embedding. And then I'm going to copy paste those sentences into the RAG. And that is surprisingly, it's only 4 or 5, 10 lines of Python. So you can copy paste a given code and you can get it to run on your own documents very easy. Now, just to wrap up, there's one thing that I want to emphasize, which I think maybe Svetlana is going to talk about, is that you cannot fully trust what the computer gives. You need to basically treat it as a new intern that has no experience and can make mistakes. So I often encourage people to use it, but always have a last step to validate, at least for now, when the data is not perfectly reliable. And there's many ways to validate. You can check by hand, but you can also do other things, such as you can run multiple models and see if they give you the same answer, etc. So I'm out of time. I'm going to skip some of the other things, but basically, to summarize, this is very useful to extract data, and the combination of running an LLM together with Python, I've seen it increase my productivity a lot in terms of the data extraction, but you need to be careful not to fully trust it always.
Thank you, Sergio. Sorry about the connection. I mean, overall, it was good. There were just a few instances, I mean, a few moments when it was...
Apologies for that. The hotel is not very...
It's not anyone's fault. No need to apologize. So we have time for a few questions.
I would have a question if I can. Hi, thanks for the nice presentation. I have 2 questions about RAGs. So the first one is, you mentioned that in order to be efficient, you needed to chunk the text and then to basically look at the chunk that was the closest to the prompt. So my question is, how do you chunk the text optimally? Is it, chunks that are predetermined based on the topic, or is there like a way to find, latent chunks perhaps?
Yeah, the first models, if somebody told you about this a year ago, they would have told you to chunk it every 500 words. So you split it by words.
But that can't work, right? Yeah.
That is terrible because it's not a semantic division. What you need to do is you split it by paragraphs, because the new models, the older models sometimes choke on a paragraph. If the paragraph was too big, they were not very precise. So the best practices today is to do it on a paragraph, but also do it, if you have enough time, sentence by sentence, and then use both of them to get the relevant paragraphs and then embed the paragraphs. But also, what we saw is that you need to embed also the paragraph before and the paragraph afterwards to give the computer some context about what is this about.
Okay, I see that. Thank you. And the second question is, you wrote on the same slide that RAGs could be detrimental if used for research projects. Can you elaborate a little bit on this?
Detrimental. Oh, no, sorry. Framework. So something that was and is still very popular are frameworks such as Llama Index or LangChain that aim to solve your problems by only having one single package in Python that does everything for you. I have some sort of issues with this, and I'm not the only one. Basically, if the alternative to running these frameworks is 10 lines of Python, you are not saving that much time. And the problem of these frameworks is that they're extremely complicated and they're very hard to modify, which is what you often want to do. And that's why I was never able to use them successfully. The alternative was always to do it on my own, and it's not too complicated.
So you wouldn't recommend to use LangChain?
No, and like a lot of people, when they start the first day, they are able to get something quickly with LangChain,
Yeah.
And the problem is that they stagnate. They cannot do anything more elaborate.
Okay. Okay, great. Thank you.
Yes.
Sergio, what's the best way to learn about the possibilities of things one can do with LLMs?
That's a great question because we have a lot of debates about this possibility. So, for instance, there was a recent paper where you have one LLM talking to another LLM about the possibility of a bank panic. And the one LLM was convincing the other that they need to run, and the other one was cautious. And the paper was about how LLMs interact and how consensus forms, etc. I don't think that's, for instance, at this level, I don't like those approaches too much because you don't know the biases implicit in the LLM. So at my stage, what I do and what I encourage people is to use the LLMs only to extract data, to get help coding, to check their writing. I would encourage you to use LLMs to write for yourself, but they're very good at spotting typos, for instance, better than Grammarly. So I'm still relatively cautious about where you can use LLMs. And I think that there's some people, especially people who are talking about LLMs a lot in public, that are perhaps too optimistic about how you can use it today.
Thank you.
I have two questions actually. One question is you mentioned reliability and reproducibility. Is it possible? I mean, I guess things will. I mean, these programs will get better. These LLMs will get better over time. But right now, for instance, if you want to extract data, could you ask the LLM to write a Python program that would do what the LLM accomplishes, so that it would be possible to replicate the data extraction, like a piece of code that would, produce the same data as the one produced by the LLM. That would be. What might this be one to improve, reproducibility, which is always a big concern in science.
People have done that. People have used basically one LLM to create fake or synthetic data to benchmark another LLM. People have done a lot. So basically, you get ChatGPT-4 and tell it, I have this employment number. Create me a German document. They talk about this in a random way, and then you know what's a number. You know the data generating process, and you can use that to validate another LLM, and it actually works well. In my cases, when I have only I still rely at least a little bit of ground truth on checking the data by hand, because that's also useful to learn how the data looks.
For sure. And my other question is, how do you choose an embedding? I guess it must be a big issue, right? How do you choose a particular embedding?
That's so if you are in a system where you cannot release the data publicly, so for instance, within the Fed, if you cannot release any data that is sensitive, you will have to use an embedding that is something you can download. And there are now good ones. Even LLMs, you can use Llama locally. What I have done is I basically use the embedding that, like, for instance, if I'm using ChatGPT, I use their embedding. Because I've seen that works better with them. If you use Claude, you may want to check their embedding, for instance. Or you can use multiple embeddings. That sometimes works. And again, the embedding is the cheapest part.
It's the cheapest, yes. Okay.
Yeah.
Are there more questions?
I have one. I don't know if we are running out of time. Can you hear me?
Yes, please ask your question. Yeah.
Hello. Thanks for the presentation. It was really a nice one, and I think I learned a lot. So my productivity will improve as well, I think. But I have a question. The first question is actually, what's the paper you just mentioned about the bank runs? Because I'm particularly curious about it. If you have any, maybe we can talk about that later. I can send you an email if you.
I know this paper. I prefer not. If I don't talk positively about the paper, I prefer not to mention it by name. But I'll send you the link of the paper. It's published.
Okay, Thanks. Thank you all. And related to that one, I would like to ask your opinion on. You say that there might be biases on LLMs, and that would hurt any insight that you can retrieve from it. But the point is, for example, if you just want to run some surveys, on some people or on some particularly chosen set of people, what would you think would happen whether you can just pre-test your survey just on LLMs? Just use ChatGPT to say, okay, ChatGPT, you are, I don't know, are Italian living in Calabria, just talking about myself, and how would you reply to these questions? And maybe you can, form some thinking out of the fake question, fake answers. What's your opinion on that?
No, actually, that would be very useful, because I've been part of surveys where we realized one question was problematic only later on, and it's very expensive to run a survey. So you can test it with a fake subject. I've seen people discover mistakes in code, in logic, in some other things by testing it against an LLM. I wouldn't necessarily include the answer of the LLM as part of the results of the paper, because you don't know how to interpret them. But using them for training and preparing for the survey, that actually that's definitely a very good idea.
Okay, thank you.
Thank you for this very good set of questions. The audience is very knowledgeable, already, I guess, about LLMs. It's now time to move to the second paper. So Svetlana, the floor is yours.
Thank you so much for the invitation. I hope you can see the slides.
Yes.
Let me know if something doesn't seem to be working. Okay.
It's working. Yeah.
So this is a joint work with Jules, Mayuk, and Varun. And in this paper, we're obviously going to be talking about economic sentiment and how one can use text-based data in order to measure it and see its informational content. And obviously, expectations and sentiment are absolutely crucial ingredient that drives decision-making of economic agents. We have seen tons of evidence coming from the micro level, but also it is obviously fundamental even at the macro level, because going back to the old debate about, say, even the sources of the business cycle fluctuations, to a large extent, this is the debate between the shocks to fundamentals or the shocks to sentiment of the economic agents. That said, identifying and measuring those shocks to sentiments is, of course, an incredibly difficult problem, because we don't know how to measure it in practice. And so there exist different proxies that have been suggested by various people from the literature. The one that is most famous and still most popular so far are usually measures that are based on surveys. But there are, of course, problems with surveys. Not only they're expensive to run, as it was just mentioned, but also surveys are something that you cannot easily extend in neither time series nor cross-section. That is, let's say you're interested in more looking at the business cycle fluctuations, long-term economic growth. You cannot extend a survey into the past to cover more business cycles. You also cannot extend surveys in the cross-section. So, for example, some of the measures that we have are available only at the national level, but we cannot zoom into what actually happens within each state, nor can we extend it to other countries. And so what this paper is about is essentially one of the attempts in which how we can relax this type of limitations. And in this paper, we're going to be using 170 years of data from local economic newspapers. And we're going to use this data in order to build local and national levels of economic sentiment. So first of all, a few words about the data itself. The last 2 years, you have seen a lot of the papers talking about big data. This data set is actually big. So it contains about 2 billion articles. And actually those local newspapers, out of which we have 13,000, they start in 1736. We're not going to use all the local newspapers all the way from 1736, because to be honest, we don't have a lot of economic data to also compare it with and analyze. So as a result, we're going to be focusing on the period of just about 170 years. Given the sheer size of the data, and this is 100 times larger than English language Wikipedia, we are not able to use the most sophisticated current ways of processing text. In particular, training not only LLM, but also BERT is just going to be not feasible given the sheer size of the data. When we started working on this project, we looked into potential costs of implementing various methods, and we find out that it will cost us more than $500,000 to do so, to train even a relatively sort of like simple version of BERT or something like that. So given these limitations, and given once again the size of the data and the nature, we're going to use the best methodology that is still remaining feasible. And that is going to be a combination of several things. First of all, we're going to be relying on word-to-vec. That is, we're going to be using word vectors based on neural networks. This procedure is going to allow us to build an automatic dictionary that will be specific to the economic language. And we're also going to be using measure of the sentiment that will allow us to produce a continuous score of the sentiment. So this is going to be much, much better than, for example, word count or anything else that historically people have been using in this type of context. Furthermore, in all of those steps that lead us to the construction of the sentiment indices, we are going to be relying on the procedures that have specifically been tested also in the context of historical literature. And this is important because there is a whole, literature out there on computational linguistics that looks at how these modern methods to analyze text, whether they do actually a good job at historical data or not. That might have different embeddings, different type of language, different tone, and so on and so forth. So we've been quite careful in looking into what is available and what has actually been tested. But the bottom line is, ultimately, we are able to build the measures of economic sentiment that are available not only at the country level for a very long time series, but also at the state level. Obviously, while we're going to be looking at the state level, we could have also aggregated the data to the level of the city or the level of the county. You basically, as long as you have the locality of those newspapers, this is what is going to, drive the ultimate measure. But now that you can have it, what can you say? What about the properties of those measures? And importantly, what is the information that is contained in this text-based news economic sentiment? Now, sentiment is a very loaded word. And so it is used, well, specifically by economists, in a variety of different settings. They actually mean very different things. So for the purpose of this paper, we're going to broadly define sentiment as just some general positive or negative coverage of economic news. And this is going to be also consistent with the dictionary definition of the sentiment. But going back to the meaning of it within our economic language, it could actually mean very different things. So for example, it could, in terms of the style of coverage, go all the way from sheer facts to something that just looks like irrational exuberance. In a more financial language, if we are thinking about economic news or the type of perception that we are kind of uncovering with a sentiment, go all the way to cash flows, let's say talking about expectations of the fundamentals, all the way to news that normally would be considered to be as discount rate shocks, something that is just related to expected returns. And the thing is, when you construct any text-based measure of the sentiment, doesn't really matter what is the source or what is the method, you're going to be somewhere on this plane, okay? And ex ante, you actually don't know where exactly you're going to end up with. Depends on the data source, and it depends on the method quite heavily. And this is precisely why we need a battery of various empirical tests to figure out the property of the economic news-based sentiment, okay? So, how are we going to do this thing? We're going to run different types of predictive models. We're going to embed sentiment score in different versions of information sets. And so we're going to look at what kind of incremental power it brings to the table. As a result, we'll be able to say where exactly on that plane our measure seems to be located. So what do we find? At the level of the country, sentiment clearly has a business cycle pattern. Interestingly enough, even though the Michigan survey is something that we have never used in this analysis, it tends to have a very robust and high correlation with the Michigan survey. It also leads the survey of professional forecasters in terms of the GDP prediction. It leads GDP growth, employment, consumption, services, even when we control for various versions of the past fundamentals. Interestingly enough, it even ends up to be kind of leading the changes in the Fed funds rate monetary policy, particularly during recession. And that type of predictability seems to be large, not only statistically, but economically as well. This type of analysis also carries over to the state level. In particular, the level of the state economic sentiment also tends to predict local economic growth, even when you control for the country level sentiment and local economic conditions. Okay? Interestingly enough, we also observe that there is a huge amount of local variation in economic sentiment across different objects. Now, in particular, the common trend across all the states drives only about a third of the overall dynamics. That kind of makes sense, because if you think about events like, let's say, dot-com bubble, it had very different impact on California versus Texas or Georgia or New York. So it shouldn't really come to you as a surprise that there is a lot of the cross-sectional variation out there. And obviously, this is something that unfortunately we wouldn't be able to pick up with existing measures of surveys. Now, I will not be able to go through, obviously, all of the results, but let me try to at least, focus on the general idea behind the method and the empirics that we uncover. So once again, our data, we're going to be looking at the subset, those things over the last 170 years, because that's going to be the focus of our economic time series. The data generally has unbalanced coverage, and so in the paper we used different types of methods like sampling or using the whole data set to train different models and see where results are coming from, and we find out that all of them are going to be consistent across all of those different approaches. Typically, when you try to measure a sentiment towards something, it always proceeds in 3 steps. Step 1, we need to create a dictionary of relevant words or phrases for the topic. That is, we need to figure out when a particular article talks about the economy or whether it talks about sports or something else. Step 2, we need to identify the tone of that thing, the words, whether they are positive or negative. And step 3, we basically need to merge those 2 dictionaries together in some sense, where we need to create a weighted average score that represents the document. So in each of those steps, we're going to be doing the most appropriate or the most advanced, approach that would allow us to implement this task, once again, given the feasibility constraints enforced by the sheer size of the data set. So for the automated dictionary, we're going to be dealing with a word-to-vec, which is based on neural networks. So one of the benefits of this approach is that it's going to produce an automatic dictionary related to this certain set of, seed words in some sense, that are based not just words, but on phrases as well. And as a result, it creates not just a list of 10 or 20 or 30, but actually thousands of different terms that might be related to each other and are often used together within the same type of neighborhood. So for example, here is a word cloud of words which are most related to the word economy. This is far from being the old dictionary that we use in the analysis. This is just a tiny, tiny subset, but it just gives you an idea behind, what are the most kind of relevant terms. And here you see all sorts of things. Trade deficit, inflation, recession, consumer spending. There is a chief economist in one corner, and I think in some other corner, if you look really closely enough, you're even going to find a phrase, Chairman Allen. I dare you to say, but I would not really think that any of the normal short economically related dictionary would come up with the word as Chairman Allen as one of these sort of key phrases in the economic language, but there it is. So things make sense. Now, automated measure of the word sentiment. We need to isolate whether the language is positive or negative. So we're going to follow Hamilton's approach, and again, based on neural networks, we're basically going to start with a certain seed words, in which case the positives are going to be related to expansion, growth, profit, optimism, opportunity, profitability, bullish, so all of the usual suspects. And they're going to look for similar words that have been used in exactly the same type of context, the same type of sentences, And so this whole algorithm is also going to propagate through the whole space of those language, and it is going to create a continuous measure of the sentiment. For example, here are the top 0.1% based on the polarity score that would be counted as positive. Profit, success, interview, expansion, advantageously profitability, things like that. Again, makes sense. What about the negative words? Here we have also usual suspects: bankrupt, unsuccessful, failure, insolvent, constriction, shrinkage, so on and so forth. So all of these are going to be considered to be somewhat of a negative connotation, okay? Now that we have a whole spectrum of positive words related to the economy, we also know the whole set of language when article talks about the economy overall. We can use these two dictionaries to create a weighted measure of the two. So we're going to produce a vector representation of the text, and we're going to measure the similarity between those vector representation on the new page and the economic dictionary, weighted by the word sentiment score. Obviously, now that we can do it for each page, we're going to aggregate it to the level of the city, county, state, and ultimately country. Okay. A few words about general properties and advantages of this measure. So first of all of those ingredients have actually been tested in the context of historical data. And so as a result, they have been actually known to produce, reliable approach to analyzing this type of data source. Furthermore, this is an almost fully automated way to construct topic-specific dictionaries. That means that it is not restricted to just the word economy, but in principle, you could try to apply it to any other topic: gender, race, crime, housing, inflation, whatever you have in mind. Obviously, this sort of signal-to-noise ratio potentially is going to vary across them, depending on the coverage, depending on how precise your original, seed words, and how well-defined is the language related to the topic, but nothing restricts you from applying the same technique in all of the other contexts. But it also is very flexible in the sense that it works with not just words, but phrases. It automatically deals with negation. So, for example, we'll be able to differentiate between something being good or not good. And also it produces a continuous measure of the sentiment score. So word, let's say good versus excellent, or bad versus, disaster. All of those things are going to be embedded there as well. So this is the country level economic sentiment measure that is resulting from this procedure. And as you see that it has a lot of the clear, business cycle type of fluctuations, like, it drops during times of the recession. But also, looking at this graph, we were actually originally puzzled by the following feature. If you look at it closely, then starting from the 70s, it seems like there is a negative trend. And this is puzzle because actually, if you think about it, the economy has been doing quite well over the last 50 years. So why is it that the economic sentiment is becoming more and more negative? The conjecture that we had in mind was that this has nothing to do with the economy per se, but is much more of a general feature of the sort of journalism, coverage, that they tend to focus more and more on the negative, spin of the same type of news. And so to test this hypothesis, what we did, we decided to build a similar measure of those pages that had nothing to do with the economy. So that would have, any of those words related to the economy, and ultimately talk about weddings or movies or, sports or weather or, Kardashians or whatnot. And what we find out is that they have almost exactly the same negative trend that started around the 70s. So interestingly enough, this increased negativity that we see coming from local newspapers is also something that has actually been confirmed by journalists that studied the language used by the various sorts of media throughout the last century. And so this is the same thing as also can be uncovered using the average tone of the articles in Wall Street Journal, and also even our own, BBC marathoning archives. All of them have been becoming increasingly negative. And if you read the literature, on this study of the journalism and computational sort of linguistics, what people would argue is that the driving force here have been an increasing competition across both the landscape of the media, also obviously newspapers trying to compete first with the TV for the attention of the readers, and then even more so with Twitter and other, modern media outlets. So negative news, they attract attention. That is something that has been well documented in the literature, and unfortunately they do sell. So the word is not becoming worse. It's just the coverage that is becoming much more negative as the time goes by. And some anecdotal evidence, about a decade ago, one of the local one of the local newspapers in Russia actually decided to fight this negativity bias. And for one day, they decided to publish only positive or neutral news. So during that day, they lost 2/3 of their readership. Okay. Now, once you know that there is this general trend that seems to be common across, different types of coverage, that means that you can also use it to essentially detrend the original measure of the sentiment. And this is what you end up with the blue line over here, something that looks much more stable and much more sort of, cyclical. Now, the red line over here I'm plotting is actually the Michigan Consumer Survey. And you see that, throughout the whole time period for which we do have data for the Michigan survey, they have remarkably stable relationship with each other, both during expansions and during the recessions. You will also see that there is a bit of a divergence starting in 2016, basically following the Trump election. This is where they see that there's been a bit of a gap between the Michigan Consumer Survey and the coverage of the local economic newspapers. That said, most of the time the correlation between them is remarkably high and stable. That said, national trend in general explains only a small part of the overall variation of economic sentiment across different states. In fact, only about 1/3. And there is a huge amount of heterogeneity across them. So, what the sentiment does? The first thing that we can easily show is that it tends to lead economic growth. In particular, leads economic growth, especially if you look at the previous quarter, but also even the longer lags provide additional predictive power for the economic growth going forward. Now, this is the analysis that is done using the quarterly data, so it starts in 1947. But using historical medicine archive data, we can also extend the analysis to 176 years, and we find out exactly the same robust predictability. Obviously, we lose quite a bit of statistical power because the number of observations is not as large, but this type of predictability seems to exist even in the 19th century, sort of before, the creation of the central bank system. Now, when we are thinking about the coverage of the economy and this type of predictability that seems to exist out there, it could come from two sources. Either there is a coverage of something related to future, in a sense, something related to expectations, or it could be talking about something that already happened or is happening right now, and then because of some sort of embedded persistency, would see it, propagating into the future. Using exactly the same methodologies that I outlined earlier, we can create the measures of the economic sentiment that relate to future news. That is something that literally starts with the word future, expectation, next year, and so on and so forth. And we find out that all of the predictability for the GDP that we uncovered is completely originated from that future thing. So to us, this seems to talk much more to the role of expectations, rather than just deliberating, existing on the past events. And once again, this predictability exists not only at the level of the country, but also the level of the state, where local economic sentiment seems to also lead economic growth going forward. Now, the news-based economic sentiment also has a distinct information compared to one of the best predictors of the GDP, which is the Survey of Professional Forecasters consensus variable. And in fact, it leads the SPF, and it is going to lead GDP, even conditional for SPF, also put into the same specification. It also has a place even within the specification of the Taylor rule. So here you see a simple estimate of, Romer and Romer version of the Taylor rule, where we augment, the standard specification by also incorporating sentiment over the last, couple of quarters. What we find out is that the sentiment is important, particularly during the recessions, where one standard deviation decrease in the news-based economic sentiment over the past 2 quarters leads to 25 basis points decrease in the Fed funds rate. This is a large economic effect, and this is something that obviously is important to understand. Now, what is the reason, or what is, again, the sort of informational content of this type of predictability? So on one hand, you could say that it makes perfect sense, because you have just shown to me that this seems to be a leading indicator of the GDP. And as the monetary policy is supposed to be forward-looking, it should rationally incorporate all of that soft information, which is contained in the newspapers, in order to implement optimal policy. So it turns out that you can actually try to decompose its impact. So the sentiment that is related to that, predictive power for the GDP relative what else is out there. And so within this Romer and Romer rule, the predictability that I showed you before, it seems to go above than what would be implied by just the predictive power of the economic sentiment on the GDP. So this is not kind of a mechanical analysis, and there is something else that definitely seems to be going on. Now, there are many different stories for the economic growth, and most of the macroeconomic variables and most of the macroeconomic models of business cycles that start with sentiment, they usually operate through the capital channel. That is, imagine that there is an entrepreneur, they get a positive shock to sentiment, they are optimistic about the investment opportunities, and so they start investing. And then ultimately that leads to increase in the economic growth and creates, the boom and bust type of cycle. Interestingly enough, we find no relationship between the news-based economic sentiment and proxies for this investment side of the channel, that is investment or industrial production. Instead, all of that predictability that I've been talking about seems to going through the labor channel, that is employment, consumption, services, durable consumption, things like that. So this is the labor side or the demand side of the economy in some sense. And this obviously poses considerable challenge for existing models of the business cycle fluctuations, because most of them are written from the producer side. Instead, we find out this sentiment-related predictability potentially operating through the demand side of the economy. So I think I'm already out of time. And in this paper, we basically try to provide a twofold contribution, where first, we create a measure of this country and statewide economic sentiment for almost 200 years. And in particular, in doing so, we found a way how to try to separate the pure sentiment from the economic one, essentially debiasing existing measures that would otherwise be exposed to this increasing negative slant that we've been observing over the last 50 years. And in particular, we uncover that there is extraordinary heterogeneity of economic sentiment, both across time and space. Using incremental power relative to various versions of the information sets, we find out that this data set and this method is much more consistent with news-based economic sentiment, essentially containing expectations of something like future cash flow news, compared to the usual perception of sentiment being just irrational exuberance, animal spirit, or some sort of a discount rate type of shocks. And it has a very important role for many different contexts. So obviously, local economic and GDP, consensus forecast, monetary policy, and a lot of other things. And I think we're just beginning to uncover what exactly can we do with the text data, given the rich information source. And there are many, many other applications that we're bound to see in the near future. Housing, migration, employment, drugs, obviously political partisanship would have been increasingly important over the last, few years, and many more to come. Right. Thank you so much.
Thank you, Svetlana, for this very exciting presentation. Do we have questions?
So, Svetlana, can we design trading strategies in real time to exploit sentiment?
So this is something that I would be cautious on, because as we know, most of the predictability in the stock market is coming more from discount rate, shocks rather than the cash flow news. And this is why designing a trading strategy, especially at the relatively low frequency around it, is not something that we would advocate to do. In fact, at the monthly or quarterly frequency, this measure of the sentiment does not predict neither the stock market nor inflation in any way. That said, and this is something that I want to be also quite kind of cautious about, obviously, since we have daily data on those newspapers, we can also build a daily version of the sentiment. With the daily version of the sentiment, we do see some predictability of the stock market. This is not in the current draft of the paper, but hopefully, soon to come. But the challenge there is that some of the newspapers are actually released in the morning, while others are going to be released in the evening. And so without having a detailed data set on the actual timing of the issue of those newspapers, it would be extremely difficult to figure out what type of news they cover, from yesterday, in which case that would be the basis of the trading strategy, or from already happening today, in which case, the timing might be an issue. So for example, Wall Street Journal is released in the morning. So there we know for sure what type of news they're going to be talking about. But given the sheer, 13,000 newspapers, there is no centralized data set that would allow us, unfortunately, to really disentangle which one's which.
How long does it take to generate the sentiment index?
Long. And not only it takes in general a lot of time, but also, to be honest, takes a lot of money.
I see.
So, I mean, obviously, the most kind of computationally intensive thing is to try to train this underlying model, produce all the embeddings and so on and so forth. And so that is the part that took us a lot of time and money. And that's the part that's done. But once you have it, it's super fast.
Thank
Yes.
you.
And obviously, we're going to be happy to share, all the time series and everything else once we kind of finish the revision of the paper and we settle on this steady state methodology. Yeah.
Giovanna.
May I?
Yes.
Yeah. Hi, Svetlana. It's very interesting. I was just surprised about the trending that you underscore, and I was wondering whether this predictive power is related mostly to the first subperiod than to the second one, because as you were mentioning, the economy was diverging in the vis-a-vis the sentiment index.
Yes. So to be honest, we were also surprised to see this type of trend. But interestingly, the predictability is actually quite stable across all those horizons. So for example, we looked at the predictability also within the last, just 50 years or within the last, 70 years. And we saw that, for example, the R-square for the GDP on that, annual data, sort of the Madison, archives data, it actually is like 20%. So this is a really sizable amount of predictability that is definitely a robust feature of the data. The challenge here is that even though there've been kind of this divergence across the sentiment, is what is actually the causal thing for those results that we uncover. And this is something that we are careful about not to overstate. And that's why I try to kind of use the word, leading instead of, really sort of predicting or, something else. So we're not saying that the sentiment is causing those things. However, if you were to actually write a model where sentiment does have a causal, predictive power for the business cycle, this is what you would actually see, that agents are not so much reacting to the, let's say, actual, happening to news about like cash flows or something else, but they seem to be much more driven by their own perception of what is going on. So any model of the expectations is going to start from expectations to, decision-making of the agents. So that said, once again, I want to highlight that this type of economic sentiment is much closer to the expectations and the cash flow news compared to traditional measures of the sentiment. So if you're thinking about, let's say, Michigan survey, type of thing, there is a very nice paper by Simpson, Barsky, and AR back in, I think, 2012, where they uncover using VR a somewhat similar type of relationship. That Michigan survey actually also tends to be sort of a leading indicator for the GDP, either because it contains, again, some version of the expectations of the agents, or it becomes some sort of like a self-fulfilling prophecy, and manifesting through the demand sort of based channel of the business cycle. That is something that we still are not able to distinguish given the data at hand. And we need here both structural models and much more empirical work to figure this out.
So Svetlana, I have actually a related question and another question. My first question is regarding the Michigan survey. Do you find that to predict like national economic activity, your index is superior to the Michigan survey, or does it, since they're so correlated, do you find that the quality of the forecast is about the same? My second question is, of course, there's much more in your work than the national predictions, but do you see that as the US economy is becoming more integrated, do you see that the importance of having local data, local news, becomes less relevant? Do you see such trends in your data?
So let me start with the first question. The answer is it depends. So in particular, depends on the type of the outcome variable that you consider, because obviously they're going to have, different predictive power for different aspects of the business cycle. So partially, I think that is also related to the source of the data. So for example, the Michigan survey generally asks about sort of the economy, perception. Given this type of measures, we can also compute it with respect to, let's say, I don't know, unemployment or consumption or services or everything else. And obviously, these are going to be the things that people are usually kind of care about. And so the local newspaper is usually going to talk about like unemployment, I don't know, local, businesses closing down. So this seems like sort of like a demand or like human sort of, labor side of the economy in the first place. So this is why, depending on the outcome of the variable, you're going to see that one or the other is going to have somewhat a better predictive power. Michigan survey also, over the last several years, as you saw, have been decoupling from the news-based economic sentiment. And this is something that people have also already researched over the last few years. And in particular, they found out that Michigan survey seems to be also be decoupling from other measures of expectations of the economic agents. And it is much more driven by political partisanship over the last 5-7 years compared to almost the whole kind of, time series before. So since we do not see the same type of thing happening to the kind of local newspapers, despite what you generally kind of think about it, then we think that kind of going forward, that predictability and the gap between the two probably is going to become even more pronounced. Now, the other dimension is the importance of local economic news, and in particular, as throughout the whole kind of time series. So that is a very difficult question. The number of the sheer, local newspapers have been changing. There've been, a lot of them went out of business. Some of them have been acquired by, larger publishing house. And as a result, they have been sort of, centralized between each other, in some sense. Competition with TV and, social media has also been a challenge for a lot of those things. So to be honest, it is an open question to which extent, for example, people also right now, the last 5 years would be relying on this thing, or they would be, using something else, or how we're going to see this measure of the economic sentiment, 20 years from now. We do see variation across the states. That is a stable feature of the data. So, for example, that roughly, 35% that all the states have in common, it is fairly stable across different sub-periods that we considered. So whether that is a reflection of, again, actual economic conditions, or whether it is a reflection of the coverage, local newspapers, of those economic conditions and expectations going forward, partially also driven by the partisanship bias, it is something that we do not know yet. So the relationship between coverage and sort of partisan slant, political slant, is something that also have been a lot of the focus of recent research, and the kind of analysis there is sort of mixed, because a big part really depends on the data that you consider. And a big part of that data hasn't been sort of properly, standardized, analyzed, and merged with other characteristics. So for example, who is the owner of each of those newspapers, whether it's been acquired by, private, I don't know, some a private equity company or not, which has been also operating over the last, 10, 20 years. And there are a lot of other things that we still don't know, unfortunately, about the media coverage and what actually drives it in the recent years.
Yeah, that makes a lot of sense. Thank you very much.
Sure.
Can I ask a question? So there's the Baker and Bergler sentiment index that is used quite often for sentiment analysis. How does it relate to your measure? Have you computed the correlation for the national index?
They're very different. So first of all, a lot of the measures of the sentiment that exist out there have been most of the time used in sort of, let's say, finance literature. Usually these are discount rate shocks. So this is the stuff that predicts returns. And that's why kind of we call them discount rate shocks. So some of them might be interpreted as, rational discount rate shocks. Others could be, irrational discount rate shocks. But whether it's a sentiment based on, Raven Pack, or whether it is based on Twitter, it actually seems much more like discount rate shocks. Our measure, at least at the level of, let's say, monthly, quarterly frequency, for sure, seems to be much more as the cash flow expectation. So it's much more related to the sort of business cycle of the economy. And from that perspective, it actually kind of stands apart from all that literature, which, to be honest, have been actually a challenge for those papers, because there are many people have been trying to use text data to figure out, some sort of predictability for real economic outcomes. And it has been quite challenging to do so. But either, partially due to the nature of the data that we use, or due to the see that there is a sizable, cash flow news and sort of expectation type of component here. Furthermore, some of the measures, alternative measures existing of the sentiment, they also operate cross-sectionally. So for example, if you're based on Twitter or something else, they're going to be a very short time series, but you could have, for example, some mentioning positive or negative of different companies. Yeah. So this is really more a reflection of the economy as a whole, like local economic conditions. So we're not doing some sort of cross-sectional firm level comparison here. It's more of a time series thing. Primarily because we really wanted to have this like long time series to figure out the relationship with the business cycle, again, going back to sort of the fundamental debate of sort of like Lucas versus Keynes on, what looks like the business cycle fluctuation seem to depend on.
Question. Have you thought about using this for identifying bank runs or economic panics, which were, I think, very common in the past in the US, but there's not much data about it?
Not yet. I think this is a terrific idea. So we've been already kind of brainstorming, other things that we could do with this data, especially now that we kind of also extended it to go to the daily frequency. So we have, a lot of the variation there. And so I think this would be a terrific place to look at. Absolutely. Actually, another thing that we really wanted to look at, but not something more related to the economy, but it's more related to crime. Because a lot of the different sort of crime attacks, if you think about like terrorist attacks or anything else, they seem to emerge from like nowhere, kind of like unexpected. But we would really love to see if it's possible to somehow look at the kind of local economic news or like coverage or other things to see whether there is something that we can identify at the local level. But once again, given this automated approach to creating, dictionary related to specific topics, I think there are so many things that can be done with this data. I mean, housing is also another thing that we are quite curious about. Yeah, but I really like the idea of bank runs. Yes, would be great.
Thank you. I think we're running out of time. So I think this was a terrific session. So I'd like to thank again Svetlana and Sergio for participating in this session, and I wish you a great summer. So thank you again.
Thank you very much.
Thank you.
Thank you.
Bye.
Best wishes to
So
you
much.
all. Bye. Thank you.